All right, so this one, we're still in 2.7, but this is going to be a linear regression. So I told you guys I always want to talk about like what the words mean. So linear means line, right? So the connection on a line. And regression means closeness of the values. So we looked at yesterday, we looked at the scatter plots, and we said if it had a positive correlation or a negative correlation, we talked about strong or weak. Linear regression is really if it is strong or weak. So we have a value, we're going to call it the correlation coefficient. Correlation means connection between the values. And coefficient means the number, the actual number. So it's going to give us an actual number that's going to be the connection between the values. So we want to look at that and decide if our linear regression has a strong or a weak connection, okay? So when we're looking at this, if the correlation coefficient, if the absolute value of the correlation coefficient, which we're going to call R, is greater than or equal to 75, we're going to say it has a strong correlation coefficient. Now, we're going to do this in the calculator. When we do it in the calculator, it's going to give us a decimal, so we're going to say 0.75, but as a percent, it's like 75%. Above 75% is going to be strong. If it's less than 75%, we're going to say that it's weak. The reason that I do the absolute value is a positive one means that it's a strong positive, and a negative one means that it's a weak, or sorry, a negative one means that it's either a strong or a weak negative, okay? So if it tells me negative 0.9, that's strong, it's just a negative correlation, okay? So we're going to do this mostly on the calculator. But what we're really looking at is we're looking at the connection between our values and we're looking at when we put a line in there to make a linear regression, how close are all the values to this line? That's what we're looking at. If the values are close, we can use this to make a good prediction. So if it has a strong correlation, we're going to say, well, we can make a good prediction off of this. We can predict based on our input what the output will be. And the correlation coefficient is kind of showing us like how much off should we expect to be. So if the correlation coefficient is 0.95, then I should expect that my number I get for an output is very close to the actual number that I would expect to find. So I'm going to show you guys how to do this. Of course, you don't have a calculator at home, so it's going to be very difficult, but we're going to be doing it on the calculator. The first thing that we have to do is we have to turn a thing on called diagnostics. So it's under catalog. We're going to press second and the 0 button for catalog. I don't want to press down until I get to the diagnostic, so I'm going to press this button right here, X to the -1. It says D above it, so that gets me to the D's. I'm going to go down until I find diagnostic on and hit enter to select it, and it just says it on my screen, diagnostic on, so I hit enter again. Let's see if I can zoom this in a little bit. Once the diagnostic is turned on, I just need to put in the value. So I'm going to use an example from the book. I'm going to use the example on page 143, minutes played and points scored in a basketball game in 10 games. So I go to stat, and I'm going to go into edit. So I'm going to hit enter on edit. In the first column, I'm going to put all my X values. I'm just copying this off of page 143. So it tells me 28, 35, 8, 20, 39, 23, 19, 27, 15, and 30. You do want to double check that you have all of your numbers in correctly, because if you don't, it's going to give you a very messed up answer. So we're going to look at our numbers again and make sure that we got them all correct. So 28, 35, 8, 20, 39, 23, 19, 27, 15, 30. We're good. Now we're going to go over to the L2. L2 is going to be all of our Y values. So it tells me 16, 13, 2, 12. Whoops, I did that one wrong. 12, 31, 10, 9, 15, 4, and 19. One thing that you double want to make sure is that these line up the same. That means you have the same number of X's as the same number of Y's, and I do. Now I'm going to quit. After I've put it in, I'm going to go quit. So I'm going to hit second and mode to get out of there. Zoom back out. The next thing that we're going to do is we're going to make the calculator actually calculate it for us. So we're going to hit stat for statistics. We're going to go over to calculate, and we're going to calculate the linear regression. Remember, that's what it was called, and that's what this says right here. Linreg means linear regression, and it's in the form AX plus B. So I'm going to select that, and I'm going to hit enter. Now remember that our correlation coefficient is the R value, so we're looking at R. It tells us 0.885, etc. So remember, anything greater than or equal to 0.75 is a strong correlation. So this is a strong correlation. And then I'm going to use the rest of the information to write the equation. So if you look at this, it tells me it's in the form y equals ax plus b. It tells me that a is 0.7746. I'm just going to round it to 3 decimal places. So I'm going to make it 0.775 and then x plus, and it tells me b is negative 5.800. Again, 3 decimal places, negative 5.800. What this is telling me is I can use this equation to make a prediction for any input values. Meaning, if I want to figure out how many points I can expect to score with 100 minutes played, I plug that in for x. So I'm going to do 0.775 times 100 minutes plus a negative 5.800, which I didn't need the 00. Tells me I should expect to score 71.7 points. So that's how we can make a prediction. The prediction really helps us, the correlation coefficient really helps us see if our prediction is any good. So this should be a pretty good prediction based off of our correlation coefficient.